The flying controls in the Whirlwind were once again a reflection of Petter's design philosophy in being innovative and not following the then normal conventions. All the movable surfaces other than the hydraulic flap and slats were operated by control tubes rather than the conventional twin cables. Even there, Petter did not use the normal dual push and pull system, but adopted a single tube push-pull system for each surface. While having the advantage of never losing tension or loss of positive movement, the system was mechanically complex, with many universal joints and connectors, requiring multiple roller brackets to support the tubes and keep them in alignment. Following the single tube design, the rudder bar, as in the Westland Lysander, utilised a central pivot about which the bar and pedals rotated through an inclined arc. As against the dual system using separate pedals running in parallel as in the Spitfire, Hurricane, Typhoon, etc. Further complication being the adjustment for the pilot's leg length. The conventional star wheel and screwed rod system, adjusted by the pilot's foot to move both pedals fore or aft, could not be used in the Petter design. The central pivot supported an aluminium carriage. The carriage housed a large diameter tube with a series of holes along its length. The one-piece rudder bar surrounded the tube and was so designed as to slide along it. When positioning the rudder bar, the flat lower surface of the centre of the bar is bearing on the carriage slideways to prevent any lateral rotation of the bar. The adjustment being operated by a Bowden pull cable in the cockpit, releasing a pin, allowing the pilot to push the whole rudder bar to his preferred position. An internal spring returning the rudder bar to the short leg position when required. Quite ingenious when compared with the complexity of the dual pedal system in common use. However, an odd quirk of the Whirlwind system being, if the rudder bar was not directly over the pivot point, the operation of the rudder bar had a tiller effect as it would move off centre. The control column is a conventional spade grip with a 2.5:1 mechanical advantage. The spade carrying the pneumatic operation brake lever and the gun firing button, the button operating the armament and the gun camera. A separate button, also fixed to the spade, was for the independent camera operation. The column pivoted on a spindle and yoke housed in an aluminium casting. The lower end of the column formed a clevis which housed the spherical bearing end of the elevator control tube. Above the lower clevis, two plates form the cruciform housing for the port and starboard aileron control tubes. The Whirlwind had no provision for the pilot to alter the aileron trim. This was a static operation for ground crew, possible on the port wing only. The rudder could be trimmed positive to negative by a small handwheel located on the top of the rear spar on the port side of the pilot's seat. The wheel operated a chain connected over a pulley block to cables that then ran down the fuselage through fairleads to the differential rudder mechanism. No example of the handwheel exists, so a 3D model was reverse engineered from available information and photographic images. patterns were produced for the castings, and the fully functioning trim wheel was manufactured. The elevator trim wheel was an interesting exercise. The handwheel was the same as that used in the Lysander, but the winding drum, indicator and mountings are completely different. The Westland Fighter project had the opportunity to purchase a Lysander mechanism. However, it was not in the best condition and very expensive. Part of the Whirlwind Fighter project ethos is to preserve historic artifacts. With this in mind, a decision was taken not to purchase the Lysander mechanism, just to hack it to pieces for the handwheel. The Whirlwind Fighter project was fortunate enough to be able to take scans of the handwheel. From the scans and the photographic information we have, a 3D model was produced. From this, patterns were produced and a fully operational replica was manufactured. The one part we have no evidence for being the elevator position indicator. The Lysander, Spitfire, Hurricane, etc. all employed a pointer following a large pitch threaded collar orientated in the horizontal plane. Not so the Whirlwind. It too used the threaded collar and pointer, but the indicator operates in the vertical plane. Unfortunately, in all our information and images, the actual mechanism is hidden. So if anyone out there has any knowledge, we would be more than grateful to hear from you. The Whirlwind Fighter project is a not-for-profit charity run by a group of dedicated volunteers. If you feel you could assist in recreating this iconic World War II fighter, please visit our Facebook and web pages. Any donations can be made through our GoFundMe page. Also, please visit our active partner in the Whirlwind Fighter project and future home of the Whirlwind, the Kent Battle of Britain Museum. Many thanks.